Assalamualaikum and hello to everyone. So in this video tutorial, we will look at the third example for chapter 5. So this third example involves a simple ducting layout as shown in the figure given here. So we have a ducting system. Okay, so from the question we can see that the equal friction value HF here is 0.4 water gauge per 100 feet. Okay, so HF is equal to 0.4 water gauge per 100 feet. Okay, or 0.004 okay water gauge per feet. Alright, so the question asks us to calculate what is the pressure loss due to friction inside the ducting system. So pressure loss due to friction is for value HF. Okay, so this one is pressure loss due to friction is HF. Okay, is the value for HF in units water gauge. Okay, and velocity here. Okay, number 2 velocity here is velocity V in units FPM. And then the ducting sizes. Okay, so we know that for ducting system it can either be rectangular, okay, rectangular or square. Okay, rectangular or square, so we have to find the size. Okay, and or if we want to use round ducting also, we have to find the diameter. So the units for rectangular or square size ductings inches, and units for diameter also in inches. Okay, neglecting the fitting losses. Okay, the maximum ceiling height is 16 inches. So ceiling height 16 inches refers to the, if we were to look or draw, okay, our space from the side view. Okay, so let's just say that this is our space, and then we have a space here in between our ceiling. So here the bottom part here is our ceiling, and the top part here is our roof. So in between our roof and ceiling here, there is a space for us to install our ducting system. So the height or the maximum height here between the roof and the ceiling is 16 inches. Okay, in other words, our ducting system, okay, when we install our ducting system here, okay, the size cannot be more than 16 inches. Okay, so if we want to use rectangular or square, the height, okay, if we want to use rectangular or square, the height here maximum will be 16 inches. If we want to use round ducting, the diameter here maximum will be 16 inches. Okay, so that is what we obtain from the question. Okay, so here we have the layout. Okay, so we have A to B and then B to C, okay, as requested by the question. So for A to B, CFM is 2000, the length is 10 feet. From B to C, the CFM is 1000, okay, and the length is 3 feet. So to solve for this question, to solve for this question, we have to draw the table, the equal friction method table. Okay, so this is called the equal friction method table. Okay, because the method we are using to size or to find the size for the ducting size is called the equal friction method. Okay, so this is the equal friction method table. Okay, so we can fill in. Okay, so the equal friction method table has 8 columns. So we have the section column, we have the CFM column, we have the ducting length column, FPM column, our friction, okay, HF per 100 feet, our size, diameter, our size in rectangular size, and also in pressure loss in units with water gauge. Okay, so we have the rows. So the number of rows depending on the number of sections. So here we have two sections, A, B and B, C. So we have two rows here. So we can fill in. So for A, B and then B, C. Okay, so for A, B, CFM from the question 2000. For BC 1000. Okay, for length 10 feet. And then for BC 3 feet. For FPM, this one we will read from the chart. And then HF per 100, we know that from the question is 0.4. And since the method is called equal friction, so for BC also, the value for HF over 100 is 0.4. Okay, equal friction method. For diameter, we will read from the chart. And then for the rectangular ducting also, we will read from the chart. For pressure loss or friction loss in units water gauge, this one we can calculate first. Okay, so for AB, the equation we will use is HF in units water gauge per 100 feet times with the length in units feet. Okay, so for AB here, for example, alright, so for AB here, the HF per 100 is, let's use a different color. So AB here, 0.4 water gauge per 100 feet. Okay, times with the length 10 feet. Okay, so we can get here 0.04. Okay, in units water gauge. So here the value is 0.04. For BC, same as AB just now. For BC, okay, 0.4 water gauge per 100 feet times with 3 feet. So we can cancel and we can get 0.012. Okay, 0.012. Okay, let's check. Okay, 0.0012. Okay, alright, so 0.012. 0.12. Okay, alright, if I'm not mistaken. Alright, 0.4 times 3, 0.12 divide by 100. Okay, so 0.0012. Okay, so we have three values which we still have to read from the chart. Okay, so now we have to look at the chart. Alright, so this is the chart we are going to use. Okay, we have seen the first two examples on how to use the chart. So for AB first, okay, we try to solve for AB first here. Okay, so for AB, CFM is 2000. Okay, so we know that the CFM is 2000. So we can look for 2000 here. Okay, and we know that the value for HF over 100 is 0.4. So here. Okay, so using these two values, HF over 100 feet, okay, is 0.4. Okay, and then we have CFM 2000. So using this value, we will find the FPM. Okay, how much, and then the size of the diameter. Okay, so we have to use our ruler. Okay, so use our ruler here, and then we can draw the line for here, straight line. Let's say here up to 2000. Okay, so from here draw the line up to 2000 here. Okay, and then we can also draw the line for the CFMs 2000. here. Okay. Alright. And then we can plot. Okay, so we know that the point of intersection here is here. Okay, so for diameter, okay, we can read for diameter straight. If we look carefully here, we have 14 inches. Okay, so for diameter here, the answer is, okay, so 14 inches here. Okay, exactly on the 14-inch line. Okay, so we can read here. So this one is the diameter for AB. So we can read right here 14 inches. Okay, for FPM, okay, we can draw the diagonal line here from our point of intersection. Okay, here. Okay, straight line here to the top here. So we can draw to the top or to the bottom. So if we draw to the top, it will be somewhere here. Okay, so we can move the ruler. So we can see that here, the intersection here, FPM for A, B. Okay, so here we can see that it is in between 1800 and 2000. So we can write, okay, 1900, okay, and in between. Okay, the FPM. Alright, so that is for AB. Alright, now for the rectangular duct. Okay, so for rectangular duct here, we will use this chart here. Okay, for rectangular duct. Okay, for rectangular duct, we have to use this chart. So we know that the diameter here, the curved line, diameter line here, for AB is 14 inches. Okay, so for AB now, from diameter 14 inches, okay, we want to convert it into rectangular, or okay, rectangular first. So the rectangular maximum height is 16 inches. So what is the width? Okay, so what is the width? So for maximum 16 inches, so we can plot first for maximum 16 inches. So here we look for 16 inch here. Okay, so we can draw the straight line. Okay, to 14 here. Okay, to 14 inches here. Okay, and we can read for the width. So we can read here approximately here, and we can read it here. Okay, okay, approximately. Okay, so 10.5. So if we want to use 16, okay, if you want to use 16, it will be 16 times inches times 10.5. Oh, sorry, 11. Sorry, not 10.5, 11. Okay. But remember that if we want to use rectangular duct, okay, if we want to use rectangular duct, we have to make it as square as possible. Okay, so as square as possible. So we can adjust the height. Okay, we can adjust the height. We can adjust the height by reducing the height. So we move it to 15. We cannot go more because the maximum is 16. So we will use less. Okay, so 15. So 15 here. If we were to use 15, okay, we can get that the height here is approximately, let's say here 15. Okay, so okay, 15 inches here. Okay, so 15 we can get 12 width. Okay, so as you can see, it's becoming more square. Alright, so if you use 14, okay, we can get 14 times here. Okay, if we use 14 here, okay, so 14 also we can get around 14 times 12. And if we use 13 here, okay, let's just say we use 13 here. Okay, so our intersection line is there. And if we draw our horizontal line, okay, here, we can get that for 13 inches high, we can get also approximately 13 inches wide. Okay, so we can also get 13 inches here, 13 inches wide. So the best size for our ducting is 13 inches times 13 inches. Okay, for AB. So we can fill in the answer for AB here just now. So FPM, we can either write 1950 or 1900. Okay, so approximately, approximately. And then the diameter is 14 inches. And then the rectangular ducting is 13 times 13 inches. Okay, so we do the same thing as for BC. Okay, so for BC, the first chart here, so on the okay, sorry. Okay, so for BC, alright, so for BC, the CFM is 1000, so we can draw the 1000 line here. Okay, here 1000. Alright, so intersect here also at 0.4 water gauge. So for diameter, okay, so for diameter we can draw the line here. Okay, here, diagonal line. Okay, we try to draw as straight as possible here. Alright, so alright, so the line here for diameter BC here. Alright, so here the diameter for BC. Okay, and then we can draw the line for FPM. So for FPM, if we were to draw the diagonal line also here on the right hand side, here, okay, straight line. Alright, so we can get the FPM here for BC. Okay, let me remove the ruler. Okay, diagonal line here for BC. Alright, so if you want to read the values now for AB, for BC here. So diameter, alright, is approximately 11 inches. And then for FPM, okay, so you can see in between 1600 and 1800, so we can read as precise as possible. So FPM will be approximately 1700. Okay, now to change into square, okay, so we use the same method as just now, but now instead of 14 we look for 11, but we don't have 11 here. Okay, so we only have 10 and 12, so we have to draw an imaginary line. Okay, imaginary line here between 10 and 12. Okay, try to draw an curved line. Okay, let's say this is our curved line. Try to draw as nice as possible. Okay, then we use the same method just now. So maximum, remember, maximum now for BC also, maximum will be 16. Okay, so maximum height will be 16. Alright, so for BC here, maximum, okay, maximum will be 16. Okay, so for maximum of 16 inches, okay, 16 inches, it will be 7.5 here. Okay, so for 16 inches, it will be 7.5. Okay, but remember, as square as possible. So as square as possible, we reduce the height. So we look at the best possible fit. Okay, so if 15, we can get 7. If 15, not 7.5, 6.5. Okay. So if 15, we can get 7. If we use 14, we can get 7.5. Okay, if we use 13, we can get approximately 8. Okay, if we use 12, we can get around 8.5. If we use 11, okay, 11 here, if we draw properly the line, here, okay, if we draw properly the line, okay, if we draw properly the line here, 11, okay, we can get 11 times 9, okay, alright, 11 times 9, if we use 10, okay, it will be 10 times 11 here, if we see properly. Okay, here 10. Okay, up to here. So the best possible fit, okay, the best possible fit for BC in terms of length times with height. So we can get here. Okay, 11. Okay, so for BC here, remove the ruler. So for BC, the best possible fit is 10 times 11 inches. Okay, so we can fill in the table just now. So for FPM, approximately 1,700. Okay, for diameter just now, 11 inches. And for rectangular duct, 10 inch times 11 inch. Okay, so this is the solution on how to fill in the table for the third example involving equal friction method. So thank you for your attention and have a good day.